All right, hey everybody, welcome back to 3.2. 3.2 is going to focus on slope of a line, okay? Slope of a line. Slope measures the steepness of the line. If slope is positive, it goes uphill from left to right, so it looks like that. If slope is negative, if we use m for slope, if slope is negative, if the m number is negative, it goes downhill like that, right? From left to right, downhill. All right, so if slope is 0, if m equals 0, it's a horizontal line. And if the slope is undefined, we can't really measure the steepness of a vertical line, right? Because does it go vertical and go uphill or downhill? You don't even know. So it's either infinitely steep or infinitely negatively steep. But anyway, if m, the number, if the m is undefined, and a number is undefined when you divide by 0, so when you use a slope formula and you get 0 in the denominator, if you get 0 in the denominator, it's a vertical line. Okay, so here's this important stuff you need to write down. Slope is equal to rise over run. It's the change in up and downness divided by the change in left and rightness, or rise over run. The change in y over the change in x. And its formula to find slope given 2 points is y2 minus y1 over x2 minus x1. And then here's some of the stuff that I mentioned earlier. If m is 0, the line is horizontal. If m is undefined, the line is vertical. Okay? All right. We're going to practice finding the slope using that formula. So we'll have, when we have a point like this, we have 2 points. So we can call our first point, the first point. How about if we call the x-coordinate of the first point x1, and the y-coordinate of the first point y1? And then this could be x2 and y2. Now, keep in mind, it doesn't matter. If you call this the first point and this the second point, and you plugged them into the formula, it wouldn't matter. You'd still end up with the same slope. So let's try. M is equal to 3 minus negative 1 over negative 5 minus 2. All right, now we'll simplify that. I'm going to add the opposite there, and I get 4. And negative 5 minus 2, I'm going to add the opposite again, and I get negative 7. So negative 4 over 7 is my slope, right? Same as 4 over negative 7. Tell me about that line. Does it go uphill? Does it go downhill? Is it horizontal? Is it vertical? No. No, only one of those. It goes downhill. That line would travel down 4 on a coordinate plane, down 4 spaces, every time it went over 7. Okay? Always read the line from left to right. Okay? Down 4, right 7. We'll always move towards the right. We read math the same way we read books. You don't want to read books from right to left, do you? So we always go down 4, right 7. All right, let's try this one. Let's do m. Okay, so I'll call this x1, y1, x2, y2. So m equals negative 3 minus 5 over 2 minus 2. So I get negative 8 over 0. Uh-oh, you can't divide by 0. You can try your calculator if you want, see what it says. But that's an undefined number. You cannot divide by 0. When we say undefined, that's what we're talking about. So tell me about this line then. Yeah, it's vertical, up and down. So like something cool, if you were to plot these points, this first one, and I went to the right 2 and down 1. And for this one, I went to the left 5 and up 3. And we connected the dots to graph our line. Well, that line, look, it goes downhill just like our slope suggested it would. And if I go to this point and I count down 4, 1, 2, 3, 4, and I go to the right 7, 1, 2, 3, 4, 5, 6, 7, it takes me to that next point. So slope works. If I was to graph this one, we go to our original points of 2 to the right, not 5, so 1, 2 to the right. We have a point there, and if the other point would be to the right 2, to the right 2 and down 3. So look, this one gives us that vertical line, right? So the graphing of the points matches the calculation of the slope using the formula, right? Okay, cool. Math's pretty cool like that, right? Okay. Now look at this one. We're gonna find the slope from an equation, and you might think back and be tempted to, older classes where you solve for y to find the slope, but I wanna broaden your horizons a little bit, and we're gonna look at slope from, if you recognize, this is standard form from the last lesson, this is standard form. What we're gonna do is we're gonna find the slope by finding the x and y intercepts and looking at the behavior of the line from there. Don't you worry, we'll get into slope-intercept form soon enough. Slope-intercept form I'm a big fan of. It's the grandfather of all linear forms of equations. It's the first ballot Hall of Famer. But we need to recognize the uses of standard form as well. So let's find the x-intercept. Remember, the x-intercept, we replace y with 0. We're gonna get so good at this we can do it in our head. If we replace y with 0, this y term would go away. And I would have 3x equals 12. What value of x would x need to be to make that true? If that term went away, x would need to be what? It would need to be 4, right? So I would say that the x-intercept is 4, 0, right? Okay, for the y-intercept, what's the value of x at the y-intercept? X is 0, right? So that would make this term go away. And I would have negative 4y equals 12. Well, tell me, if this term went away, what would y have to be in order for that to be true? What would negative 4, we could just divide by negative 4. 12 divided by negative 4 is negative 3. So we have 0, negative 3. So those are my intercepts. And that's enough to graph the line. All right, I'll graph the y-intercept first at 0, negative 3, right there, right? And I'll graph the x-intercept now at 4, 0, right there. And then if I connect the dots, there's my line. Now we can find the slope by looking at that graph, because if we look at this graph, to get from this point to that point, how many did we go up? We went up 1, 2, 3. And we went over 1, 2, 3, 4. So my n is equal to 3 over 4. So I want you to be able to find slope from all different ways. From the formula, from an equation of standard form, trouble speaking, guys. From the formula, from the equation in standard form, from a graph, from an equation later on in slope-intercept form. We're gonna be slope masters. Okay, so that's the first part of 3.2. Thank you so much.